Alright, this is my second reassessment on forces, and the problem reads, the boulder on the slope below has a mass of 60 kilograms. What is the boulder's acceleration if friction is insignificant? Also, what is its acceleration if friction is known to be 45 newtons? So I'll start off by drawing my little free body diagram. And it shows the boulder rolling down the slope with our force of friction pointing up the slope. We have our normal force pointing straight up, and we have our force of gravity pointing straight down. We also have it pointed this way of a force, which shows the force perpendicular, and our slope right here also our force right here shows our parallel force with our force applied rolling down the slope. Okay, so what do we know? We know that the mass is 60 kilograms. We also know off the top that 9.8 acceleration of gravity, millimeters per second. So we need the acceleration. Okay, so we have our problem, or we have our equation right here, which is the force of gravity equals the mass times force of gravity. So we plug those in, equals 60 kilograms times 9.8, which gives us 588 newtons. So we have our angle right here, which is 25 degrees, so we plug in sine 25 equals the parallel forces divided by 588, which we got right here. So we have forces parallel equals 588 times sine 25. Plug that in a calculator, and that gives us 248.5 newtons. Alright, so now we can find the forces applied equals the mass times the acceleration. So now that we have the forces applied, 248.5 newtons equals the mass, which is 60, times the acceleration. A little algebraic, when we get A equals 248.5 divided by 60, and that gives us our first answer, which is 4.14 meters per second squared. Okay. So our second one, what is its acceleration if friction is known to be 45 newtons? So again, we have our mass, which is 60 kilograms. We have our force of friction, which we now know is 45. And we have our forces applied, which we now know from here, 248.5 newtons. So what is its acceleration? So we have our formula, F net equals forces applied minus force of friction. And we have F net equals mass times acceleration. So we start off with finding F net, which is F net equals 248.5 newtons minus 45 newtons, and that gives us 203.5 newtons. So we can use that to find our answer, which is going to be F net equals mass times acceleration. So we plug in our F net, 203.5 newtons equals the mass, 60 times acceleration. So a little algebraic, and we get A equals 203.5 divided by 60, the mass, and that will give us our answer of 3.39 meters per second squared. And this is my second reassessment on forces.